Welcome to this podcast on an integrated scenario. This will involve a discussion about a particular scenario which will be discussed in the podcast, and all the questions will be related to the hardware, software, internet and networking, data and information, and solution development related and applied to this integrated scenario. These topics are from question 8 of the 2024 Computer Applications Technology November Paper 2 exam or theory exam for the IEB. There are 3 ways that you can engage with the content of this podcast. If you want to test your knowledge, then download the questions covered in the video first. The link to the PDF is in the video description. Then go and attempt those questions, and finally come back and listen to the podcast so that you can compare the discussion with your answers. If you want to use the podcast to learn new information, then first listen to the discussion, then download the questions, the PDF link in the video description mentioned earlier, and then test yourself to see how much you remember from the discussion. Or you can simply enjoy the discussion and learn more about how the different forms of computing can be applied to this integrated scenario. And now let's hear what our podcasters have to say about this particular scenario.
Welcome back to the deep dive. Today, we're looking at something pretty incredible happening in South Africa's high-end hospitality sector. I mean, forget everything you think you know about checking into a hotel.
Yeah, this is a whole different ballgame.
We're talking about luxury hotels that are using some seriously advanced computing. AI-powered humanoid robots. They even have names, Lexi, Micah, Ariel, and these comprehensive digital systems that completely change the guest experience.
They're personalizing everything, streamlining it all.
It's fascinating because you see this deep digital innovation in an industry that's traditionally been very, people-focused. And these robots, they're not just gimmicks. They're acting as concierges, waiters, room service.
And they can carry some serious weight. Meanwhile, the human staff are freed up to do what they do best, that high-touch personal interaction.
So our mission today is a deep dive. And this one is really for you, the computer science student. We're going to look past the shiny robots.
Right, we're pulling back the curtain.
We are diving into the technical stack. The core computing concepts, the hardware, the networking, the database fundamentals, all the invisible stuff that powers this futuristic operation.
We want to connect this real-world disruption directly back to what you're studying in your curriculum. So when you see a robot navigating a lobby or a guest unlocking their door with their phone, you'll know exactly what's going on underneath.
We'll explore how digital keys work, why fiber is so essential, how data is secured, basically connecting all the dots.
Yeah, the whole shebang.
Okay, let's unpack this. And let's start where every trip starts. Access. How do you get from booking online straight into your room without ever seeing a front desk?
Ah, the mobile key.
The modern experience really does hinge on the mobile key.
Yeah.
You've got an app on your phone, a secure digital key linked to your profile. But how does that app, how does it actually talk to the lock on the door and tell it to open?
Well, this is a classic application of short-range wireless communication. We know a lot of the old key cards use RFID, and we'll definitely get into that.
Yeah.
But for the phone itself, the mobile key relies on tech that's already baked into every modern smartphone.
And if we're looking at the technologies that let the phone and the lock talk to each other, besides RFID, the 2 big ones are going to be Bluetooth or NFC.
Near-field communication, yeah, exactly. And for you, as a student, it's really important to see the trade-offs between these two in a hotel setting.
Okay, so let's break that down. NFC, that's the tap-to-pay thing, right? Super short range.
Extremely short range, a few centimeters, tops. You physically have to tap or get your phone very close to the lock.
Which has its benefits, I imagine. Speed, for one.
Speed and a kind of inherent security through proximity. You have to be physically present, the data handshake is quick, it's low power, and you don't need a complicated pairing process. It's all about that tap-and-go efficiency.
So the latency is almost zero.
Practically zero. Now, contrast that with Bluetooth, specifically Bluetooth Low Energy, or BLE.
Which has a longer range.
A bit longer, yeah, maybe a few meters. And it can maintain a more complex, secure, sort of persistent connection. The lock might be constantly listening for a BLE signal.
And that changes the user experience, doesn't it? With BLE, you could maybe unlock the door while you're still walking down the hall.
You could, 10, maybe 15 feet away. And the hotel could use that connection for more than just unlocking, maybe location tracking or sending you a welcome message as you approach.
But it's more complex on the back end?
A little. It needs a more robust pairing process and secure token rotation to make sure no one can intercept the signal. And it uses a tiny bit more battery on both the phone and the lock.
But in both cases, the phone is basically acting like a super secure encrypted token.
Precisely. The security isn't just about being close, it's about the cryptography behind that digital key.
Okay, so now let's talk about the workhorse technology here, RFID. It's still everywhere.
Oh, absolutely. Staff cards, inventory, you name it. And first, we need the full acronym.
Which is radio frequency identification.
Right. And even though it might seem like older tech, its mechanism is a foundational concept in computer science, especially how it handles power.
Let's get into the specifics of how it works for a hotel door lock, based on the components in our source.
Okay, so the system needs three main things. You have the tags, the readers, and the computer servers.
The tag is the key card itself.
Yep. It has a tiny little antenna and a microchip inside that stores a unique ID. The reader is the device that's built right into the door lock.
So when you hold the card up to the door,
The reader emits a radio frequency field, and here's the magic trick. That field doesn't just communicate with the tag, it actually induces a current in the tag's antenna. It powers it up.
so the key card has no battery.
None at all. It's completely passive. That burst of energy from the reader is just enough to wake up the microchip and make it transmit its unique ID back to the reader using radio waves.
That is clever. So it's power delivery and data transfer all at once.
Exactly, but that's just the first step. The reader gets the ID, but it doesn't make the decision.
It has to check with the main brain.
Right. The reader sends that unique ID back to the central computer server. And the server does the heavy lifting. It checks. Is this ID mapped to this room? Is the guest still checked in? Is it within the allowed time window?
So the lock itself is actually pretty dumb. It's just waiting for a yes or no from the server.
It's an actuator. The authority is centralized, and that's why it's so efficient for a huge hotel. If you lose your key card, the staff just flags that ID as invalid on the server, and instantly that card is useless everywhere on the property.
A perfect example of a client-server architecture in the real world.
Couldn't have said it better myself.
Okay, let's move from unlocking doors to interacting with the stars of the show. Lexi, Micah, and Ariel, the AI robots. Their job is more than just carrying bags. They're interacting with guests. And to do that well, they need to understand emotion.
This is where we take a huge leap from simple automation to cognitive computing. The source says these robots use facial recognition to figure out if a guest is happy or unhappy.
And that underlying technology, the one that lets a robot interpret facial expressions, is broadly called biometrics.
That's the one. We usually think of biometrics for identification, fingerprints, iris scans, answering the question, who are you?
Right.
But this is way more sophisticated. It's analyzing your physiological data to figure out the state you're in. It's a combination of computer vision, pattern recognition, and machine learning models trained on just vast amounts of emotional data.
The complexity there must be enormous. The robot's camera is the input.
Capturing high-res video in real time. That data gets piped to a processor either on board or in the cloud. Then the AI algorithms start looking for features, the muscles around the eyes, the corners of the mouth, and comparing those tiny movements against its models of human expression.
And it has to happen instantly.
In milliseconds. If there's a 2-second lag, the robot might react to your frown way too late and the conversation just feels weird and unnatural.
So the reliability of that fiber network we're going to talk about is directly tied to the robot's ability to seem empathetic.
Absolutely. It's not just recognizing a face, it's quantifying the degree of happiness or unhappiness from dozens of microexpressions.
Now, beyond reading emotions, let's look at the other ways our source says biometric tech can be used in a hotel. This tech is probably all over the place.
For sure. We can break it down into 3 main strategic uses.
Okay.
First is high-level access control. So while guests use their phones or key cards, staff needing to get into sensitive areas like the server room or the finance office would use biometrics.
Because a key card can be lost or shared.
But a fingerprint or a facial scan can't. It just massively elevates the internal security. You could even have it for high-tier guests accessing an executive lounge. They just walk up to the door and it opens.
The second area is security purposes. This is more passive, right?
That's right. This is about monitoring. The biometric systems can scan dozens of security cameras at once, looking for individuals on a watch list, for instance.
Or just unusual behavior.
Exactly, like a sudden crowd forming, or someone moving in a way that's inconsistent with how guests normally move. It can flag that anomaly and alert human security staff in real time. It's proactive.
And the third use brings us back to that seamless experience. Identification purposes.
This is the real game changer for service. Imagine a regular guest. They walk into the lobby, a camera scans their face, instantly links it to their profile in the database.
Validates their booking.
And within seconds, Lexi the robot is rolling up saying, "Welcome back, Mrs. Jones. We've prepared your favorite sparkling water in room 405.
It completely eliminates the check-in desks.
It transforms identification into instant, personalized service.
That's the goal.
Here's where it gets really interesting. When we look at how the hotel delivers and processes critical information,
The whole ecosystem.
let's focus on the hotel's public-facing tech. The information points.
Yeah.
You know those kiosks or big touch screens you see everywhere. You use a menu to select services, watch videos. For a computer science student, this is a perfect real-world case study. Absolutely. And you have to start by analyzing the peripherals, the input and output devices. So let's start with input devices. The source lists a few: touchscreen, keyboard, microphone, and mouse.
Okay, in a public kiosk, the touchscreen is king. It's intuitive, it's clean, anyone can use it.
It's the primary, no question. But the others are still necessary. A keyboard and a mouse are absolutely essential for the IT staff.
For maintenance, right, they're probably hidden behind a locked panel.
Exactly. For updates, troubleshooting, changing content, you can't do that efficiently with just a touchscreen.
And the microphone.
Well, with AI robots roaming around, you're definitely going to want voice command capability at your kiosks. "Hey, where's the pool?" Or "Book me a table for two." The microphone enables that hands-free interaction.
Okay, now for the output devices. The screen is the main one, obviously, but the list also has headphones, speakers, printer, and light LED.
Right. Speakers are for public audio promotional videos, announcements. But if the kiosk is in a quiet area or you're confirming personal booking details, you need a headphones jack for privacy.
That makes sense. What about the printer? Seems a bit old school for a high-tech hotel.
You'd think so, but it's about redundancy and convenience. Guests might want a printed receipt, or a physical map of the grounds, or a confirmation code for a tour they just booked. You can't rely only on digital.
Good point. And the light LED.
That's for status indication. A green light means the kiosk is ready. A blinking blue light means it's processing your request. It's simple, nonverbal communication with the user. It's just good design.
Now, all of this, the high-def video, the real-time voice commands, the robot communications, it all needs a rock-solid network. The source makes a big deal about choosing fiber over ADSL. We need to get into the details of why fiber is the only real choice here.
Oh, it's not even a contest. For what this hotel is doing, ADSL, which runs on old copper phone lines, is a complete non-starter.
Let's go through the 6 advantages from the source. Start with reliability and higher bandwidth capacity.
Okay, so on reliability, fiber transmits data using light through glass. ADSL uses electricity through copper. Copper signals degrade over distance. In a huge hotel, a signal could get very weak by the time it reaches a room at the far end of the property.
And it's also susceptible to interference, right?
Hugely. All the electrical noise from elevators, air conditioning, lighting, it can all disrupt a copper signal, causing dropouts and lag. That would be a disaster for a robot trying to process a command. Fiber is completely immune to all of that electromagnetic interference.
So it's more stable, which allows for the second point,
Yeah.
higher bandwidth capacity.
Right. Bandwidth is how much data you can push through the pipe at once. This hotel is moving massive amounts of data simultaneously. Security camera feeds, guest streaming, robot data, biometric scans.
An ADSL network would just choke on all that.
It would grind to a halt. Fiber can handle orders of magnitude more data, so there's no congestion. The critical systems always have the speed they need.
The third advantage is future-proofing.
A huge one. You don't want to have to rip out all your cables in 5 years. Copper is basically at its physical limit. With fiber, the cable itself has almost unlimited potential. When you need more speed, you just upgrade the equipment at either end of the cable. The infrastructure is built to last.
Okay, number 4 is security. How is fiber more secure?
Well, you can, with the right equipment, passively listen to the electromagnetic signals leaking from a copper cable without ever touching it.
A data tap.
Exactly. To tap a fiber optic cable, you have to physically cut into the glass, which immediately breaks the signal and alerts the network administrators that there's a breach. It's just fundamentally more physically secure.
Next up is environmental factors.
We mentioned its immunity to electrical noise, but it's also not affected by things like lightning strikes, which can travel down copper lines and fry expensive equipment. It's also resistant to moisture and corrosion. It's just tougher.
Which leads to the final point, long-term cost savings, even though the initial installation is more expensive.
Right, because it's so much more reliable and durable. You spend far less on maintenance over the life of the network. Fewer outages, fewer repairs, fewer engineer callouts. That reliability saves money and protects the hotel's reputation. It's a no-brainer.
Okay, great. Now let's talk about how the hotel spreads information around using QR codes. We see them everywhere now. Let's walk through the exact steps a guest takes to use one.
Sure, it's a simple process. Step 1. The guest pulls out their phone. The QR code is scanned using the phone's camera or a specific scanning app.
Step 2 is the decoding part.
Right, the camera just captures an image. The software on the phone then has to read or decode that pattern of black and white squares and translate it into data.
Which is usually a website link.
Usually. So step 3 is the result. The software opens a document like a PDF menu, or it directs the phone's web browser to a specific website with all the information.
And the final step is about convenience.
Yeah, the user can then save or bookmark that link or take a screenshot so they don't have to go back and scan the physical code again. It brings the information from the physical world into their personal digital space.
Perfect. Now we need to go deeper into the real engine room of this whole operation, the database on the hotel server. This is where data integrity is everything. And we have to talk about the primary key.
Yes, this is one of the most fundamental concepts for any computer science student to grasp. If you get the primary key wrong, the entire system collapses.
Let's start with the definition.
A primary key is simply a unique value that identifies a record.
And that word unique is doing all the work there.
Everything. The moment you have two records with the same primary key, the system is broken, it can't tell them apart, it's chaos, billing errors, wrong room access, you name it.
It's all about something called referential integrity.
Yeah.
Right. The primary key from the main guest table is used to link to all the other tables' bookings, payments, service requests.
It's the anchor. It's the one guaranteed, unchangeable value that ties every single piece of data back to one specific person. Without it, you have a bunch of disconnected information that's basically useless.
So let's identify some data points that would actually work as a primary key in a hotel database.
The source gives two excellent examples. A guest's ID number, like from a passport, or the booking number.
Let's talk about why something like a person's name would be a terrible primary key.
Because names aren't unique. You could easily have two people named John Smith staying at the hotel at the same time. The database wouldn't know who is who.
And what about the room number?
Too temporary. Room 405 belongs to one person today and someone else tomorrow. It's useless for tracking a guest's history over multiple visits.
So the booking number is great for a single stay. It's unique to that specific transaction.
Exactly. It's a perfect transactional primary key. But if you want to build a long-term profile of a guest, their preferences, their history...
You need something permanent, like their ID number.
Right. That's how Lexi the robot knows what kind of coffee you liked on your visit last year. It uses your permanent ID to link your old booking record to your new one. The primary key is the digital backbone of the whole operation.
Okay, so to keep improving, the hotel needs feedback. They moved from paper comment cards to online surveys. Let's talk about why that's such a massive leap forward.
For a student studying data workflows, this is a great case study. The advantages are huge. We can list 7 of them.
Let's start with the obvious ones. Speed and cost.
First, it's just faster. The data collection is instant. No waiting for someone to pick up the forms. Second, it's cheaper. You save on printing, distribution, and all the man-hours needed to manually type the data into a computer.
And that leads to the third and maybe most important point. The data is more accurate.
Absolutely. When you have a person manually transcribing handwritten comments, errors are inevitable. Bad handwriting, typos. Online surveys eliminate that step entirely. The user's input goes directly into the system, which means the data is much cleaner.
Which means it's quick to analyze.
Instantly, the hotel manager can see a dashboard with real-time satisfaction scores. If there's a problem with breakfast service at 9 a.m., they can know about it and fix it by 10 a.m. You can't do that with paper forms.
And because it's structured digital data, it's easier for researchers to manipulate.
Yeah, they can run complex queries with a few clicks. Show me the satisfaction scores for guests who stayed in the East Wing and used the robot for room service. That kind of granular insight is almost impossible with manual methods.
The source also says online surveys get more honest responses. Why is that?
It's psychology. People feel more anonymous filling out a form on their own phone than they do handing a piece of paper to a manager. That distance encourages more candid, critical feedback, which is what the hotel actually needs to improve.
And finally, there more flexible.
Totally. You can change the order of questions, add new ones, run 2 different versions to see which works better, all without any printing costs. It's adaptive.
So when you're building these electronic forms and you need a user to pick between just 2 options, like yes, no, or happy, unhappy, what's the best tool to use?
You want to enforce that binary choice. The 2 best control fields are a drop-down form field or a checkbox.
A checkbox is simple. Checked means yes, unchecked means no.
Right. A drop-down form field is also great, especially on a mobile screen where space is tight. You click it, and the 2 options appear. You have to pick one. The crucial thing is that both methods prevent the user from typing in their own answer, which keeps the data clean and easy to quantify.
Okay, for our final deep dive, let's get into the physical hardware. Where does all this data actually live? We're talking about storage media.
Right, and we need to distinguish between the old magnetic and optical types and the modern solid-state storage.
An SSD, a solid-state drive, is the most common example. We need to name 3 other devices that use the same tech.
Okay, we can name an SD card, a USB flash memory drive, and very importantly, random access memory, or RAM.
The key thing they all share is no moving parts.
Exactly. Which brings us to the next point. All the mobile devices the staff and robots use need robust storage. Why is an SSD the perfect choice over an old mechanical hard drive?
There are a bunch of reasons. Let's start with the physical ones. An SSD is compact, lightweight, or portable.
It has to be, to fit inside a robot or a tablet. It also has low power consumption, which is critical for battery life. A spinning hard drive just drains batteries.
And it runs quietly and at a cool temperature. You don't want your luxury robot making a bunch of whirring noises.
Definitely not. But maybe the most important physical trait for a mobile device is that it's robust and durable.
Less susceptible to damage if you drop it.
Exactly. You drop a device with a mechanical hard drive, and there's a good chance you've just destroyed it and all the data on it. An SSD is much more shock resistant.
Then there's performance. Fast access read-write speed.
Vital. The robot can't be waiting for its hard drive to spin up to access a guest's profile. SSDs are practically instant, and they now come in very high capacity, so you can store plenty of data locally.
And one final advantage. It's not affected by magnets.
Right. A strong magnet can wipe a traditional hard drive. SSDs are immune to that. For all these reasons, it's the only logical choice for a mobile application like this.
But the hotel's main database isn't just on a local SSD. It's in the cloud. Let's go through the 6 key benefits of using cloud storage for their core operations.
This is a major strategic decision. First up is data accessibility from anywhere with an internet connection.
So a manager can check in on things from home or even another country.
Exactly. The second benefit is huge. Scalability. There's no need to buy additional hardware if they run out of space.
So if they suddenly get a massive conference booking, they don't have to panic and rush out to buy new servers.
The cloud provider just allocates more space for them instantly. It's elastic. They only pay for what they use.
The next 2 are about offloading risk. Data is backed up by the service provider, and the data is kept secure by the provider.
You're essentially outsourcing your disaster recovery and your cybersecurity to world-class experts. It's safer and more robust than what most individual companies could ever build themselves.
What about the 5th advantage? File extensions are not blocked.
This is a subtle but important one. Sometimes local network security is so tight it blocks certain file types you might actually need. The cloud is generally more flexible, which can be useful for storing things like training videos or diagnostic logs for the robots. And finally, it's used to synchronize files across multiple devices.
This is the glue that holds it all together.
It really is. The cloud is the single source of truth. When the front desk checks a guest in, that information is instantly updated everywhere, on the manager's tablet, in the accounting system, and on the robot that's about to greet the guest.
Okay, last piece of the puzzle. To move all this data around, everyone relies on the USB connection. What are its benefits beyond just being universal?
Oh, USB is a fantastic protocol. First, a simple design one. Modern USB-C cannot be inserted incorrectly. It's reversible.
A small thing, but it makes a difference.
It does. Second, it supports different transmission speeds, so new devices can still talk to old ones.
Which leads to number 3, high-speed transmission. Modern USB is incredibly fast, which you need for moving large files.
Fourth is its plug-and-play nature. It's automatically detected, and it usually finds the drivers it needs without any help.
It also powers the device.
Ah, a huge one. One cable for both power and data simplifies everything. And finally, it's backward compatible. You can plug old devices into new ports, which lets the hotel upgrade its equipment gradually instead of all at once.
So what does this all mean?
I mean, we've basically taken a journey through an entire tech stack. We started at the physical layer with RFID and NFC for access. Then we moved to the critical infrastructure, looking at why fiber optics are non-negotiable for this kind of operation.
Right.
We dove into the data layer and stressed just how fundamental that unique primary key is to making the whole system work. And we finished with storage, seeing how SSDs are perfect for mobile tech, while the cloud provides that central, synchronized brain.
Every single high-tech service that a guest sees.
From the robot greeting them by name to their seamless checkout, it all rests on the proper implementation of these core computer science concepts you're learning about.
The real genius here is how it all comes together to remove the friction from the travel experience, and it frees up the human staff to provide even better, more personal service. The source says the only limits are imagination and cost.
Which is a pretty powerful statement.
But, we talk about how these robots use biometrics to figure out if a guest is happy or unhappy, and that level of emotional processing it's profound.
It is, and it raises some questions. If the AI knows you're frustrated, and it links that emotional state to your permanent guest profile, what happens next?
What do you mean?
What if that data is used to dynamically adjust pricing? What if it detects you're stressed and immediately pushes a notification to your phone for a high-priced calming spa package? Or maybe it raises the price of the snacks in the minibar because it thinks you're more likely to buy them.
So the same technology that's providing better service could also be used for some pretty sophisticated manipulation.
That's a fine line.
That is a challenging and very modern thought for you to explore as you continue on your computer science journey. The tech that makes your check-in seamless is also watching and quantifying how you feel.
Something to think about.
That's all the time we have for this deep dive. We really hope this helped you connect the concepts from your curriculum to what's happening in the real world. Keep exploring, keep questioning.
And we'll catch you on the next deep dive.
To help support the channel, please click on that subscribe button and please share us with your friends so that we can help other IEB students. Remember to follow us on TikTok at Mr. Education, and remember, don't do it the long way, do it the Mr. Long way.